It's optional. You don't have to rewrite it in exponential form. But if you were to write this in exponential form, it would be 3 to the power of what equals 1 over 27. So what does my exponent have to be if I'm getting a result of 1 over 27? Negative 3. Good. For question 2, 4 to what power equals 16? 2, because x squared is 16. And for number 3, 2 to what power is 64? 6 or 8? Who says 6? Who says 8?
I was thinking. All right.
So you're gonna have a skills check. I'll let you all know, because the first one was so bad. You want this next one to be better so that last one can drop out. So these are some of the questions that'll be on the skills check, and once I know, I will give you that information. I'm not sure when it's going to be yet. Did you have a question?
I just asked if you were okay.
I'm okay.
That's sad.
I am. I'm okay. All right, so 5.5. So go ahead, title your notes. 5.5, properties of logs. So we're done with 5.4. We're moving on to 5.5. And I think I updated the due date. I don't think this is due Monday anymore. So I'm pretty sure. Did I change it over there? What did I write over there? 11/11? I think it's Tuesday though. Can somebody pull up Candace real quick? And go to chapter 5 at the bottom, because I know I changed it. I just don't remember what I changed. I think I changed it to Tuesday. Homework 20.
It's Wednesday.
Wednesday. Okay. So go ahead. So this is not due until Wednesday. 11/13. Change it over here. Okay. So Wednesday 11/13 is homework 20. Okay. So we're going to talk about properties of logarithms now, which is again going back to Algebra 2. Go ahead and glue down that handout that I had you pick up. These are your log properties. So 5.5 is properties of logs. So take a minute, glue that down. And then go ahead and copy down example A and B for product rules. So we're going to go through each one of the rules. So glue that down and copy down these two examples.
Bro, where's it at? Remember? Oh, you said my foot.
I just asked who was by your foot.
I didn't get it.
All right, so after you glue it down, go ahead and copy down who wrote down these two examples. So we're going to do product rules. So go ahead and title it product rules. So we're going to go through each one of the rules. We're going to practice expanding and then also condensing. Okay. So, for log rules, first of all, you know that it is completely expanded when you're not taking the log of more than one thing. So do you see how this says log base 3? And we're taking it of 2 and x. So according to our product rule, which let me zoom in, which you have glued down. The product rule says that if you have the log of 2 numbers that are multiplied, or 2 variables that are multiplied, we expand that with addition. Who remembers this from Algebra 2? So we're going to expand this by writing. So this is the mistake. The mistake would be, Jim Quayle, can you put your phone away? If you put log base 3 of 2 plus x, that is wrong. Okay? When you expand it, each term gets a log. So it would be log base 3 of 2 plus, and then what would I have? Log base 3 of x. That is the correct way to expand. So I'm expanding this because these are being multiplied. Remember, multiplication means product. We expand multiplication with addition. So this first one was already condensed and we expanded it. For part B, it's already expanded and we're going to condense it. So we have the log base 4 of y plus log base 4 of z. Addition, you condense with multiplication. So I'm going to write this as log base 4, and it would be y times z. So in homework 20, you have to expand and condense logarithms. So we're going to get into some more complicated equations that we will need to condense first and then solve it. So that's the first rule that you have glued down. It's called the product rule. Second rule we're going to talk about is the quotient rule. So go ahead and write that down. Quotient rule. Copy those 2 down. So when you see subtraction, I used to say subtraction means a fraction. So if you see subtraction, it's going to condense down to a fraction. Quotient means division. So quotient rule is division. So if you see the log of a fraction, we expand a fraction with subtraction. So that log base 3 of 4 over x. So again, the biggest mistake is people will do log base 3 of 4 minus x. That is wrong. Each term, when you expand it, gets a log. Okay, so the correct way would be to say log base 3 of 4 minus the log base 3 of x. And then for question B, because this is subtraction, we know we're going to condense it down to a fraction. And that would be log base 3 of 2 over 8. And you can leave it as 2 over 8, or you can reduce it to log base 3 of 1 over 4. And that's it. Yes.
So if we have like our log, like for the condensed ones, if we have like a log of 2 and like the log of 3, what would we do?
Oh, they have to be the same base. So that's a really good point. Thank you. All of these rules that you see that you glued down only apply if they're the same base. So notice when you expand it, the base has to be the same. So the bases, they have to be the same in order for this rule to apply. So that's a good question. Any other question? That's a good one. All right, let's keep moving then. Power rule, let's go ahead and write that. If you see an exponent, we move it to the front. So if you have the log of something and that something has an exponent, that tells us to move that exponent to the front. So I'm going to zoom in here. So again, if you have the log base, a number of something that has an exponent, we move that exponent to the front. That is how we expand with the power rule. So go ahead and copy that down. All right, we got that down? So for this first one, we have our power. So we have log base 4 of x to the power of 5. So to expand it, we just move this to the front. So it becomes 5 times the log base 4 of x. That's how that is expanded. And to condense it, anytime you see a number that looks like that number is being multiplied by the log, that means that that number is really a power. So this 4 is really being moved here. So that would be the log base 3 of 2 to the 4th, or log base 3 of 16. All right, so the next one, if we go back to what we did in our bell work, this is the change base, okay? So go ahead and copy this down. So this applies when we're trying to evaluate it and the answer is not a whole number. So we're going to use our change base formula. And we're going to evaluate. So again, what we're trying to figure out is 5 to the what power is going to give me 75. 7 to what power equals 18. So the power in this example has to be a fraction or a decimal. So how do we figure it out when we can't just know it? Because we know that 5 to the second is 25. 5 to the third is 125. So that means we're looking for a number between 2 and 3. So we're going to use the change base. So for this example, it's a base 5. We're going to change it to a base 10. So I'm going to go ahead and zoom in right here. If you look at what you glued down, it says that if you're trying to figure out the log base a of x, the main thing to keep in mind is that I like to say that the base is going to go in the basement. And you can change it to a common log or a natural log. So I'm going to use a common log. So to figure out what this is, you would draw your fraction bar. You would divide in your calculator the log of your big number, which is 75. Divide that by the log of your base, which is 5. Go ahead and type that in your calculator. Now, you need to use parentheses when you're typing this in. Every calculator is different, but this calculator, we can use our fraction bar. So if you type it in log 75 divided by log of 5, we're gonna go out to the thousands place, then you would get that x is approximately equal to 2.683. That is what you would get.
Should we parentheses with 75?
Yeah. Are you using the fraction button or did you use the division key? Yeah, so if you use the fraction button, you don't need to put the parentheses there. All right, go ahead and try to do the next one by yourself. See if you can figure out what that would be. And you would get the same answer if you did a natural log of 75 divided by a natural log of 5. So it doesn't matter if you use a common log or a natural log, it just has to be the same. Either way, you should get 2.683. What did you get for part B? 1.485. Who got that? 1.485. That is correct. 1.485. So if you were to type in your calculator, if you typed in 7 to the power of 1.485, you're going to get a number really, really close to 18. Any questions about that rule? Okay. Almost finished. So let's go ahead and copy this down. This is where we have multiple rules that we're going to apply. So go ahead and we're going to bring it all together. So we're going to condense both of these. And we're going to use multiple rules when we do that. Now, in order to fully condense it, that means it's going to come down to just one log. You see how we have two logs? If it's fully condensed, you should only have one log. All right, so the first thing I like to do is look for a power. So if you see any numbers in front of the word log, that means that that's a power. So we're going to start by moving that first. So the first thing I'm going to do is move this 5. This 5 is really an exponent on 4x. So that means I have the log base 3 of 4x to the power of 5 minus the log base 3 of 8y. But we still have two logs. So we have a subtraction in between our two logs. How do you condense subtraction? With a fraction. Good. So now I'm going to write log base 3. And I'm going to make my fraction. This is my numerator of my fraction. And this will be my denominator of my fraction. So my numerator will be 4x to the power of 5. And my denominator is 8y. And that is fully condensed. When it's fully condensed, there should only be one log. That's it. That's all there's to it. All right, let's look at B. So in this example, both of them have a power. So I have to move the 4 and I'm moving the 2. So that would be log base 5, 2x to the power of 4 plus log base 5, z to the 4th squared. That's my first step. Move your powers. Now this one is addition. How do you condense addition? With multiplication. So it would be log base 5, 2x to the 4th times z to the 4th squared. Now you can stop it there. Some books, or maybe, you know, like some standardized tests might expect you to simplify it. I will give full credit, but you should also know that this can also be written as 2 to the power of 4 is 16, x to the 4th, z to the 8th. So you can simplify those powers. So both would be accepted, but on the standardized test, college algebra, they may expect for you to go ahead and do that next step and simplify it. All right, last 2, and we'll be done with 5.5. We'll do some more practice on Monday. Go ahead and copy down these 2, and we're going to go the other direction. We're going to expand it. So first thing first for A, because it's a fraction, I'm going to expand it with subtraction. So I have log base 6 of the numerator minus log base 6 of y squared. That's my first step. Then I'm noticing that I have these 2 terms that are being multiplied. We got to separate those. How do you separate multiplication? With addition. So let's separate these 2 with addition. So this is going to separate down to log base 6 of 3 plus the log base 6 of x to the 7th. And I'm going to bring down the log base 6 of y squared. Now 2 of those logs have a power that need to be moved. So I'm going to move this to the front of this log. That 7 gets moved to the front of that log. And this 2 gets moved to the front of that log. So my final answer would be log base 6 of 3 plus 7 times the log base 6 of x minus 2 times the log base 6 of y. That would be fully expanded. So notice that you're going to need to use multiple rules, the power, the quotient, and the product rule. And it can be all in one problem. All right, last one. Now, before we can expand this one, we need to simplify it. Now, is anyone still copying down A before I take it away? Because I need more space. Okay. So, before we can expand question B, I need to simplify this right here. This needs to be simplified. So, I'm going to do that. So, log base 2. So, 4 squared. What is 4 squared? 16. And then x squared, y to the 7th.
So we can take out the parentheses after we
Yes, because it's all being multiplied. So there are three different terms that we have. We have the 16, that gets its own log, this gets its own log, and this gets its own log. So let's go ahead and expand it. So I have the log base 2 of 16 plus the log base 2 of x squared plus the log base 2 of y to the 7th. Move your exponents to the front. We have log base 2, 16 plus 2 times the log base 2 of x plus 7 times the log base 2 of y. Now, because this is pre-calculus, there is one more thing that you can do. Does anybody know the one more thing that you can do?
Add them all together and calculate.
No, that's an absolute 0%.
It can't be simple.
This one can though.
Could we,
Yeah, that one can actually simplify down to a whole number.
Because it doesn't have a variable.
Right. So what does that equal? What is the log base 2 of 16? 2 to the what power is 16? 4. Now, if that said log base 2 of 15, we would leave it alone. But log base 2 of 16, we should be able to simplify. So your final answer would be 4 plus 2 times the log base 2 of x plus 7 times the log base 2 of y. And you only need to do that if this can simplify down to a whole number.
But again, we don't have to do that on the test.
Yes, you do. If, and I don't know if this particular situation is going to be on the test because I haven't looked at it, but if you have something that can be simplified or evaluated, you should. All right, so that's it for today. Use this time to start working on homework 20.